This is the CNC router parts rack and pinion motor mount. It allows you to attach your stepper motor and drive it on a rack and pinion drive. So this is the pinion, and this is the rack that it rides on. I'm actually using a NEMA 34 stepper motor, and so they have a version for the 34 and the NEMA 24 motors. So I believe, at least in this configuration, it's a 3.2 to 1 gear reduction. So one rotation of the shaft of the stepper motor equals just slightly less than an inch of travel, according to the calculations. Claims to be machined from one solid piece of aluminum. This is a little cam bolt that you set. It actually pushes the motor this way, so it tensions the belt, and then you lock down the motor in these four screws. It's pretty stout. The only thing I will call out is that most of the nuts and bolts are metric on this kit, except these shoulder bolts. These shoulder bolts are imperial. So this is a 1/2 inch by 2 inch shoulder bolt with a 3/8 by 16 thread per inch threads. So if you're tapping into a piece of aluminum to mount that, it's good to know that up front. Yeah, so I guess we'll go through assembling this today. But this is the finished product. So this angle shows the importance of how much of the stepper motor spindle is coming out. Basically, we're going to mount this pulley on it, and obviously we want the belt to be straight. And so it's definitely the shaft of the motor is halfway through this pulley, but I would have liked to have seen a little bit more. But it is what it is. The other thing is that the pulley has a keyway, but my stepper motor shaft does not. It would have been nice to have that keyway. So in lieu of that, it has these set screws, and I'm just going to put some red Loctite on them to make sure, improve the odds that it won't slip and we'll lose steps, because that would be bad. So another point of sort of adjustment here is this shim. I actually machined this shim myself to better control how much of the pinion is riding on my rail. It comes, I think, with a nylon little nut that is sitting in between here, and it can be removed or, I assume, customized. So my solution was to make this collar, which sits on the inner race of that bearing, and then just butts up against the plate. Right, so here's the pinion, and then this is the gear rack that it's going to ride on. As you can see, I don't have 100% coverage. Ideally, I would have liked this pinion to be completely on this gear rail, but I had to balance that against the size of this spacer, and more importantly, how much that pulley was on the stepper motor shaft to get the motor, to get this pinion to be more on the rail. I would have had to have made that pulley go even further out on the tip of the stepper motor spindle. I just wasn't comfortable with that. So this is the compromise I made, and I guess we'll see if it's good enough. If not, I guess I'll have to revisit. So no, this is an interesting part of this design. Hope I can show it to you. Basically, inside that tiny little gap there is the shoulder bolt, and the shoulder bolt is now tight up against my aluminum plate here. And as you can see, there's a bit of play, and that is by design. So the system obviously runs up against here, but it's not meant to be completely rigid. I think there's meant to be a little bit of room there in case there's a problem in your rack or maybe some piece of debris or something unexpected happens, and the entire rack can pivot out of the way rather than break. And so there's a little bit of play here, and then there's this pretty interestingly designed non-concentric washer, and these also has 2 set screws, so it lets you sort of dial in exactly how much space, if you want in there, but still allows the mount to rotate. So kudos to CNC router parts. That's pretty wizard. Yeah, and here's the sort of the final detail, this little tension spring. And so maybe you can see, I can't actually force it, but it allows for a certain amount of deflection downwards if that were to ever be necessary. So it's a nice safety feature.